Welcome to Bhagaskara Labs, your hands-on guide to learning cloud computing step by step. In this session, we're going to explore one of the most powerful tools inside AWS for managing your infrastructure, Systems Manager, often called SSM. Now imagine this. You have several EC2 instances running in different regions, and you need to connect, run commands, update patches, or gather logs. Traditionally, you open SSH ports, manage keys, and keep track of access across multiple servers. Not only is this complex, but it also opens potential security risks. That's where AWS Systems Manager comes in. With SSM, you don't need to expose your servers to the internet. You can connect directly from the AWS Console, automate repetitive tasks, and manage your fleet of instances at scale, all in a secure and centralized way. In this tutorial, we'll walk through a complete workflow, starting from building a brand new VPC, creating subnets and route tables, then launching an EC2 instance. We'll first test connecting through Systems Manager without the necessary IAM role and see why it fails. Then, we'll attest the correct IAM permissions and confirm how the secure connection works successfully. By the end of this video, you'll understand not only how to set up SSM with EC2, but also why it's a best practice for secure and scalable operations in AWS. So, let's get started. And before we dive into the hands-on part, let's first break down what AWS Systems Manager really is, its functions, and where it fits in real-world use cases. Now that we know the big picture, let's dive deeper into what AWS Systems Manager really offers. First, centralized management. Instead of jumping into each server one by one, SSM gives you a single pane of glass to control multiple instances across regions and accounts. Second, secure remote access. With Session Manager, you no longer need SSH keys or open inbound ports. You connect directly through the AWS Console or CLI, which makes your environment far more secure. Third, automation and orchestration. SSM lets you automate repetitive tasks like patching, software installation, or configuration updates. This saves time and reduces human error. Fourth, operational insights. It doesn't just connect to servers, it collects system inventory, tracks performance data, and checks compliance, giving you visibility into the health of your infrastructure. And finally, scalable and consistent. Whether you manage one instance or thousands, SSM ensures the same process works everywhere, across multiple regions and accounts, with consistent policies. So, in short, SSM is not just about connecting to EC2, it's about managing your entire environment more securely and efficiently. Now that we understand what SSM is, let's explore the real-world functions and use cases that make it a game changer for cloud management. First, remote access without SSH. Imagine you're managing hundreds of EC2 instances. Traditionally, you'd need to juggle SSH keys, open ports, and hope nothing goes wrong. With SSM Session Manager, it's as simple as clicking a button in the AWS Console or running a command in the CLI. No SSH keys, no open inbound ports, just secure, seamless access. Next, run commands across instances. Whether it's installing software, restarting services, or checking logs, SSM lets you execute commands across multiple instances at once. Think of it like a remote control for your servers. Save hours of manual work in a few keystrokes. Then, automate patch management. Keeping systems up to date is critical, but also time-consuming. SSM's automation features allow you to schedule patches, updates, and configuration changes across your environment. You no longer have to worry about forgetting an update. SSM ensures consistency and compliance. Another powerful feature is collecting inventory and monitoring health. SSM keeps track of your software inventory, system configuration, and resource performance.
It's like having a pulse on every server, alerting you before small issues become big problems. Finally, increase security. By eliminating the need for public IPs and SSH keys, SSM reduces your attack surface. Your instances stay private, your credentials stay safe, and your environment becomes far more resilient to threats. In short, AWS Systems Manager isn't just a tool, it's your operations assistant. From secure access to automation, inventory tracking, and compliance, it empowers you to manage your cloud infrastructure efficiently, safely, and at scale.
Here's the roadmap for today's hands-on session with AWS Systems Manager. We'll follow 5 key steps to set up a secure and manageable environment. Step 1. Create a VPC and Internet gateway. We start by building our private network in AWS, giving our instances a safe place to live and a gateway to communicate with the Internet. Step 2. Create subnets and routing tables. Next, we divide the VPC into subnets and configure routing. This organizes our network and ensures traffic flows correctly between resources. Step 3. Launch an EC2 instance and test SSM. Fail. We'll launch an EC2 instance and try connecting through Systems Manager. This initial test usually fails, which helps us understand why proper permissions are essential. Step 4. Create an IAM role. To give our instance the right permissions, we'll create an IAM role. This role acts like a secure badge, allowing Systems Manager to manage our instance safely. Step 5. Attach the role and test again. Now the connection works perfectly, showing how SSM can securely manage your infrastructure at scale. By following these steps, we'll see firsthand how Systems Manager simplifies remote management, automation, and monitoring, all without touching SSH keys or exposing our servers to the public internet. Step 1 is all about laying the foundation for our cloud environment. We start by creating a VPC, your private network in AWS. Think of it as your own secure neighborhood, where you control who can enter and how resources communicate. Next, we create an internet gateway. This acts like the main road connecting our private neighborhood to the internet, allowing our instances to send and receive traffic safely. Finally, we attach the internet gateway to our VPC, linking our secure network to the outside world. With this foundation in place, we're ready to build subnets, launch instances, and manage them efficiently using Systems Manager. With our VPC and Internet Gateway in place, it's time to organize our network. We start by creating a subnet, a smaller segment of our VPC. Think of it as a street within our private neighborhood, where our instances will live and communicate. Next, we set up a route table. This acts like the traffic map, telling our subnet how to send and receive data. By associating the subnet with the route table and adding a route to the Internet Gateway, we ensure that traffic knows the way in and out of our network.
This step gives our cloud environment structure and direction, preparing the path for launching EC2 instances and connecting them securely through Systems Manager. Now that our network is ready, it's time to launch our first EC2 instance. Think of this as placing a new house on the street we built, a server that will host applications and services. We choose Amazon Linux 2, a lightweight and reliable operating system, and place it in our subnet. Notice we don't open SSH access. This instance will rely on Systems Manager for secure remote management. Next, we try to connect using Session Manager. And, just as expected, it fails. Why? Our instance doesn't yet have the proper permissions to communicate with Systems Manager. This failure is intentional. It sets the stage for the next step, where we assign an IAM role to grant the necessary access.
Our EC2 instance failed to connect to Systems Manager because it lacked permissions. To fix this, we create an IAM role. Think of it as giving our instance a secure badge that tells AWS what it's allowed to do. We select EC2 as the trusted entity, meaning this role will be assumed by our instance. Then, we attach the Amazon SSM Managed Instance Core policy, which grants the necessary permissions for Systems Manager to manage the instance. Finally, we name this role SSM-EC2-role. With this badge in place, our instance will have the keys to communicate securely with Systems Manager. enabling remote management without exposing SSH ports or public keys.
With our IAM role ready, the next step is to attach it to the EC2 instance. This is like giving our instance an official badge that grants it the permissions it needs to communicate with Systems Manager. Once the SSM EC2 role is attached, we try connecting again using Session Manager. And this time, success! The connection works securely and seamlessly, without any SSH keys or open ports. By attaching the IAM role, we've empowered our instance to be fully managed by Systems Manager, showing how AWS makes remote management both secure and efficient.
And there you have it, a complete hands-on journey with AWS Systems Manager. Today, we started by laying the foundation with the VPC, an internet gateway, creating a secure network where our instances could safely live and communicate. Then, we organized that network by adding subnets and route tables, giving our cloud environment structure and direction. Next, we launched an EC2 instance and attempted to connect using Systems Manager, and initially it failed. But that's exactly the point. It showed us the importance of proper permissions. Then we created an IAM role, attached it to the EC2 instance, and suddenly everything worked seamlessly. Our instance connected securely via Session Manager, with no SSH keys, no public IPs, and no unnecessary exposure to the internet. Through this workflow, we saw the true power of AWS Systems Manager. It's not just a tool to connect to servers. It's a complete solution for secure remote access, automation, inventory tracking, compliance monitoring, and scaling your infrastructure efficiently. Whether you manage one instance or thousands across multiple regions, SSM ensures your processes are consistent, secure, and easy to manage. If you enjoyed this deep dive and hands-on guide, make sure to like this video, subscribe to Bhagaskara Labs, and hit the notification bell so you never miss our upcoming tutorials. Your support helps us keep creating high-quality, step-by-step AWS guides that make cloud learning easier and more practical.
Thank you for watching, and I can't wait to see you in the next hands-on session where we explore even more ways to simplify and secure your cloud environment.